This edition of the Bio Report is brought to you by the California Technology Council, providing discounts on products and services essential to every startup. For more information, visit californiatechnology.org/member benefits. I'm Daniel Levine, and this is the Bio Report. Mosquitoes are more than just pesky. Certain types of the insect can serve as efficient vectors for infectious diseases that pose great harm to humans. Oxitec, a subsidiary of Intrexon, has developed a genetically altered male of the Aedes aegypti mosquito designed to mate with females to produce offspring that die before becoming adults. The effort is meant to provide a highly targeted alternative to insecticides that are broad-acting, can cause harm to humans and other animals, and may be unable to effectively reach their intended targets in urban environments. We spoke to Hadyn Parry, CEO of Oxitec, about how the company breeds billions of mosquitoes that can't reproduce, how it delivers them to where they're needed, and how the company is addressing the regulatory barriers to demonstrate its technology is safe and effective. Hadyn, thanks for joining us.
Thank you for having me.
We're going to talk about the public health threat posed by mosquitoes, the problem with the traditional approach of using insecticides to control mosquito populations, and Oxitec's unique approach using synthetic biology to target with precision the mosquitoes that pose a problem to human health. Let's start with the problem itself, though. How big a concern is mosquito-borne illness, and how is that threat evolving?
Well, it's a huge threat, really, and what is strange is that intuitively one might suppose that as society gets richer and we become more sophisticated, that the mosquito-borne diseases reduce. In fact, it's the very opposite. More people are being infected by mosquitoes and suffering every year. And the reason really is that nowadays we're all in big cities, and the mosquitoes that actually are infectious with diseases they actually live in and around the home. So, I mean, every mosquito that bites you that could transmit something like Zika or yellow fever or chikungunya has actually only hatched out about within 100 or 200 yards of where it bit you. So it's very localized. And obviously, a lot of these mosquitoes are on private properties, so public health authorities really can't get at them. But to give you a few examples, even 50 years ago, just 50 years, then very few people had actually heard of dengue fever. Only a couple of countries in the world were reporting regular cases. And now the WHO are reporting up to 300 million infections a year. So that's a rise from very low levels up to about 300 million infections per year for dengue. Then you have chikungunya, which I'm sure a lot of people haven't heard of. It actually was unknown in the Caribbean until 2013, so only a few years ago. And we had one case in St. Martin in December 2013. And following that were over 1 million cases around Central America and the Caribbean area. And then, of course, Zika, which I'm sure everyone is familiar with, where huge issues around Central America, Brazil, Puerto Rico, the Caribbean areas. So this is very much a threat that's on the increase and will continue to increase, actually, in terms of those diseases I've mentioned, but also there are new diseases that people are worried about as well. So it's absolutely, a clear and present danger.
Not all mosquitoes represent the same threat to human health. You're targeting the Aedes aegypti mosquito. Why is this mosquito a particular concern?
Because it's an urban dweller, and it just seems to be, it's highly anthropophilic, so that means it really only bites humans. And it's been adapted over time, it has adapted over time to city dwelling and just biting humans. So some mosquitoes will bite any warm-blooded animal. They might bite you, and then they'll bite a cat or a dog or a horse or a bird. But with Aedes aegypti, it's really only humans. So if you get a virus in a human, you can then transmit from from the human to the mosquito, back to the human, back to the mosquito, and you just have two hosts, the human and the mosquito. That's why it's so dangerous.
Historically, the approach to combating this mosquito has been to spray insecticides. How successful has that approach been, and what's the problem with it?
Okay, well, actually, post Second World War, it was quite successful, to be fair. The most common insecticide that was used was something called DDT, and DDT was highly, highly toxic and persisted loss in the environment. So if you sprayed DDT on the wall, it would stay there for months or even years as an effective mosquito killer. But that same persistence brings up a lot of environmental problems and some problems in the food chain. So DDT was progressively banned from the mid-60s. And that's really what's happened, is that DDT actually was quite effective as an insecticide because it is so horribly toxic. But once it's been banned, in effect, there's been no effective chemistry to replace it. And even this issue of urbanization, the lack of chemistry is one issue linked with the growth of mosquito-borne diseases. But the other one really is just the way in which we live. Many more people in cities, much more plastic in the environment, many more containers which can hold water and act as mosquito breeding sites, many more densely populated communities. So a number of things have combined. Good organisation are in the 50s and 60s in these big anti-malarial campaigns, combined with real determination. They did have an impact, but from the mid-60s, really all control has gone.
Oxitec is using genetically engineered mosquitoes as an alternative way to control the Aedes aegypti mosquito population. What do these genetic alterations actually do?
Okay, well, we have two genetic alterations. So we release male mosquitoes, and the reason we do that is that male mosquitoes don't bite. It's only the female that bites. So every mosquito that's bitten you has always been a female. So the male is pretty innocuous in itself. So we release the males, and each of these males, they carry two genes in addition. And one of those genes is what we call a self-limiting gene. Now, what we mean by that is that when this male, and we'll send out a lot, millions of them, but when these males mate with females, all of the offspring will inherit this gene, and they all die. So it's called self-limiting because nothing actually stays in the environment. The mosquitoes that we release will mate and die, or they won't mate, but they'll still die, and then the offspring will die. So nothing hangs around and stays in the environment. So that's the first gene. And of course, the more males you can put out, relative to the males that are there, is the faster you bring the population down. Because every time a female mates with one of our males, then she won't provide any viable offspring in the future. So that's the first gene, the self-limiting gene. The second gene we use is basically a color. It's not visible to the naked eye, but it's visible under a special light. And what that enables us to do is when we're releasing mosquitoes in a town or a city, we can actually look at the larvae and we can set little traps and we can look at these larvae and then we can see that some of them are red and some not. And everyone that's red has had a parent, a male parent, which is one of our mosquitoes. So by doing that, we've really got what I sometimes call a track and trace effect. We can see how effective we're being, what percentage of the population we're covering, which areas we're covering. We might find we're more successful in one area of the town, less successful in another. We can just adapt and change our strategy so that you can really bring down the whole population of mosquitoes across a whole town. And you know exactly what you're doing. It's very well targeted with sort of precision metrics, which again is a lot better than using insecticides, sort of hit and hope type of approach. So those are the two genes. There's a self-limiting gene which actually stops reproduction and hence reduces the population, and then there's this colour which allows us to judge very, very precisely how effective we're being, how many mosquitoes we need to release, how quickly the population is coming down.
To be effective, as you mentioned, you have to release millions and millions of these at a particular site. It would be impractical to genetically alter these on a one-by-one basis. How do you reproduce a mosquito with a gene designed to prevent its reproduction? What's the production process at work? How does it work?
Okay, so, we have a trick up our sleeves, actually, which is we have an antidote to this reproduction block. So when we actually rear the mosquitoes, we rear them in water. Well, I mean, all mosquitoes, or these mosquitoes, they rear themselves in water when they're either larvae or pupae. So the life stages are egg going to larvae, going to pupae, going to adult. So when they're larvae or pupae, they're actually raised in water. And if we put into the water an antidote, then this reproductive block, the self-limiting gene, is effectively neutralized. So we can rear them perfectly happily in very, very large numbers. So we have a factory in Brazil, in a town called Piracicaba, outside Sao Paulo, and that has a capacity of actually rearing 60 million male mosquitoes a week. So if you walked in there, for example, you would see rooms full of big cages where we have our males and our females mating. They produce eggs. We then harvest those eggs. We put them in these big aquaculture rack systems, which are filled with water and food. And those are reared up to pupae stage when we then put them ready, the males ready for release after a few days.
How are you able to just release males?
Oh, because we can separate the males and females, because there's a neat piece of mosquito biology, which is that the female pupae are much larger than the males. So literally you can sort them very effectively by size.
Where has this been deployed to date, and what do you know about its effectiveness?
Yeah, well, we first started, we obviously did a lot of testing. This mosquito strain that we produced, and it's just been reproduced, as I've explained, in a factory ever since. We first produced this in 2009, so we did about 7 years worth of internal testing, making sure we had all our ducks in a row. Then we first moved into outdoor trials in the Cayman Islands in 2009. We then followed that up with trials in Panama and in Brazil, several trials in Brazil. We're now doing trials in India. Colombia have said they want to go ahead, and hopefully we'll get underway with trials very shortly in the US as well. So you've got a fair number of countries there. What we've seen in every case, actually, every single trial we've done, we've reduced the population of these mosquitoes, the wild ones, wild Aedes aegypti, by over 90% in about 6 months. So that means if you compare two areas side by side, one where you use our mosquitoes and one where you don't, the difference is that we'll have 90% less mosquitoes after 6 months than in the area where we haven't been releasing. Now, just to give you some sort of feel, if you took the best funded, best managed mosquito control program using different chemicals and different approaches, you might have expect a result of around 30 to 50%. But in our case, every time it's 90%. And the reason for that is really it just becomes a numbers game. The females can't tell the difference between our males and the wild ones. And the more we release relative to the numbers that are out there, the faster we bring the population down. So it is effectively a numbers game.
How do you go about deploying these mosquitoes? How do you determine where to release them, and how are they actually released?
Yeah, so we actually release them by van on the ground. So we have vans going around. If you look inside the van, you'll find one of our staff with different pot with lots of pots of mosquitoes, about 1,000 in each pot. We have a GPS system, so we've pre-planned a route around the town or city, and every time we go through a GPS point, the guy releasing or the girl releasing has an iPad. That iPad beeps at them, and they literally will release 1,000 mosquitoes out of the window. Now, if you're in the street, if you remember the public, what you actually see is you see a van coming down the road. It doesn't stop. I mean, you can release mosquitoes on the move. And every now and then you see a little puff. It looks like a little puff of smoke, actually, coming out the window. But, of course, 1,000 mosquitoes, then they dissipate extremely quickly. And that's all you see. So you just see these little puffs of mosquitoes being released every few hundred yards. And that's really the key. You need to know where to release and how many. And that's where the red colour comes in, because it gives us this ability to monitor throughout on a weekly basis throughout the whole area how effective we're being. And if we need to release more mosquitoes in one area, then we know that next week we'll increase the numbers in that particular area. And then if we need to release less, we'll release less in other areas.
Altering the genetics of a living organism and releasing it into the environment can cause some concerns. There's a case to make that this is safer than insecticides, but what do we know about the safety of this approach? Are there concerns about disrupting a food chain or biodiversity or other issues?
Well, we know an awful lot, actually, because we've been at this for a long time. And I mean, as I said, we've had this product effectively since 2002. And it's really being rolled out now, 2017. So, that's a long pathway of testing and proof. So we've been testing outdoors since 2009. We've taken this through regulatory systems, so very independent regulatory scrutiny in different countries, Brazil, Panama, Cayman, the USA. In the USA, we are regulated by the FDA, Food and Drug Administration, and they gave us a clean bill of health in Florida to carry out a trial. We've taken this through the World Health Organization. They have a group there, and they recommend this actually for countries wanting to try different approaches to combat this mosquito that spreads Zika. And even last week, in the European Union, the Dutch regulators basically have looked at this and basically said, that it poses negligible risks to human health and the environment.
How big are the regulatory barriers you face from country to country?
They're very significant in terms of in terms of novelty, really. I mean, we are the first company, always, in any particular country to say we'd like to bring this method forward and make it available. So all regulators will place a very, very high hurdle on the first of a new approach, whether it's a new drug or whether it's a new approach like ours, or in any walk of life. Anything new is always judged, very harshly indeed. So the novelty means that, I mean, you are judged by very high standards. And we've gone out of our way actually to try and make sure that we are working with the best regulatory agencies like the FDA or those in the European Union, so that you have you can reassure people. So it's been through those. We have not had a single major issue, and even if you think about it, from the start. This Aedes aegypti, if you look in the context of the US, for example, or the Americas, this insect shouldn't be here. It's an invasive species. It was largely wiped out. It came from North Africa. It was largely wiped out in the 50s and 60s through these big anti-malarial campaigns using DDT. So where it's actually reinvaded, principally it's reinvaded in the last 50 years. So it's not indigenous, it shouldn't be here, it doesn't play a major part in any particular food chain. And then you actually look, what are we doing? Well, we're putting something into the environment that by definition is self-limiting. It can't persist because you're blocking reproduction. So everything we put into the environment will die within a few days, and if it reproduces, the offspring will die. So it's a dead end. And again, we can, because it has this colour, we can monitor it. So we can actually, show people what's going on all the time. So I think this is probably in many ways, this is the product that's had the greatest amount of environmental and regulatory scrutiny of anything we use in the mosquito world, even though it's relatively new.
You mentioned in the U.S. you're under the purview of the U.S. Food and Drug Administration. How did the FDA end up with you, and what is the regulatory hurdles you're going to have to cross to satisfy it?
Sure. So when we first came into the U.S., when we were invited in actually, because there was a problem down in the Florida Keys with dengue fever in 2009 and 10, so we were invited in because the mosquito team there realized that they didn't actually have good products to cope. So we originally approached all of the major agencies to see which was the right regulatory path. That took some time to figure out, because sometimes it's not obvious which regulator is the one that will actually be the focal point. Now, what the FDA did is act as a sort of coordinating body. So while they've been looking at our dossier, they've also been talking and discussing with expert groups like the CDC. They've been dealing with, also involving other regulatory teams like the EPA, Environmental Protection Agency, so that they themselves have got a very sort of broad cadre of opinion and expertise to draw on. But I think the key thing from our point of view is, I think we're towards the end of that process. I think we'll get approval to go ahead shortly. In actual fact, when we talk about the regulatory system, what most regulators will want you to do is actually to do a relatively small sort of proof of principle or trial on the home soil, even though we have data from several other countries going back since 2009. So what we'll do in the US is maybe one or two sort of small stage trials, really confirming what we've seen and shown elsewhere. And then we'll be able to go forward and make it more broadly available.
And where are you in terms of commercial rollout, and where do you see the biggest opportunities for this approach?
Well, I think from a commercial point of view, where is the market? Well, the market is everywhere. I think that's one of the challenges we've had, because this mosquito is everywhere. From if you sort of take a line from really from Miami or from Florida right the way down to Buenos Aires in Argentina and across the world, that it's a tropical, subtropical zone. where this mosquito has invaded. And so Singapore, Malaysia, Philippines, Indonesia, India, Africa, they've all got this mosquito. So again, what we've tried to do is make sure we're not just working in one or two countries. We obviously can't work everywhere at the same time. So we've looked at working in Brazil, because it is probably the most advanced program we have, because Brazil, as you know, has over 1 million cases of dengue every year, and Brazil was the home to, of the big explosion in Zika cases. So they probably have the biggest health risk in Brazil, and also one of the best sort of reporting systems. So Brazil is where we're very much focused. India has a major challenge, many cases of dengue and chikungunya every year. So that's why we've chosen India. We'd like to go ahead in one of the Asian countries as well, so we get people in that area understanding the approach and being able to see it firsthand. And of course, Colombia have said they wish to go ahead as well, and there's a lot of interest around the Caribbean. So, really, in terms of how fast you move forward, it's a question of where the disease is, which is everywhere, where the mosquitoes is, which is everywhere, and then whether they have a regulatory system, and then just how many countries can we take on at any one time.
Hadyn Parry, CEO of Intrexon's Oxitec. Hadyn, thanks so much for your time today.
Thank you very much.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.